Okay, we are going to get started. When you turn in your practice, when you turn in the warm-up, I want you to also make sure you turn in the practice number 3, not number 4. The first 3 questions. What operations require a common denominator? Very good. Not supposed to be a trick question. What about multiplication and division? Do you have to have a common denominator to multiply or divide? No. Well, I posted the notes online. It's still y'all's responsibility to go back and look at them. If you were not here for any of the days, number one, it's your responsibility to go back and look, but we're reviewing a lot of that stuff right now. So even if you didn't know, you should write those things down. 2, why do we check for undefined values? Because why? Because you can't divide by 0. Very good. Because you can't divide by 0. Does that mean that x can't be 0? No. X could be 0. It might not be able to be 0. It could be a restricted value, but you can't divide by 0. Doesn't mean that x can't always be 0. Where do we find undefined values? Where do they come from? If it is a fraction, do we look at the top or the bottom? You look in the denominator. Okay, we find undefined values in the denominator. For some problems, like if you look at question number 6, see how there's not factors in question number 6? It's just x's and y's and they're written next to each other. For problems like that, it's pretty easy. It's like x is not 0, y is not 0. But when you have factors, remember you do the opposite sign of what's in there. We have all of these things written down. So on the quiz, every problem that you are solving, you have to be able to find undefined values. And we're going to get practice because we have 3 problems that we're going to do together. Okay, let's do round 2. Madeline, you still my reader? Okay.
What are their metrics? Money. Paperwork. Diary.
How about a gun?
Magazines. Oh, yeah.
Probably. I can't hear you guys. What? What do you think?
Drugs. Oh.
It's Family Feud, so my guess is, I guess there's weapon and magazine, but maybe it's PG.
Yeah.
Okay, that just told us a lot about your classmate. All right, the problem says simplify. Show all your work and box your final answer. Pay attention to the operation. That should probably be the first thing that we identify because you have questions. There will be addition, subtraction, multiplication, and division. 4 different operations, and you have, I think there's like 6 questions. So some of them will repeat. You've got to know what operation you're doing. So what, when we do multiply is in, or sorry, division is important. What's the method that we use when we divide? There's something special about division. Back page of day 1. So let's give ourselves a reminder. Keep, change, flip, because it is division. What is our first step really with multiplication or division? Do what? Not yet. First step for any problem, aside for the ones that are written like number 6, it's the same first step for everything. Starts with an F. Factor. Factor. So I am going to factor. Anytime I have 2 terms, I'm going to double check to see if there's a GCF. There's nothing you can divide 2 and 5 by, so that doesn't factor. X plus 2, that doesn't factor. Also, as I rewrite these, it's sometimes helpful to put them in parentheses. I know that keep, change, flip means that I'm going to change the operation to multiply and I'm going to flip the fraction. The only thing I have to be careful about is that because it's division, I need to make sure that because there's 2 they're both the top and the bottom end up being the denominator. So when I find my undefined values, I have to look in the denominators, but it's both in the second one because they'll both end up being a denominator. But I can go ahead and change the operation as I rewrite it. What about x squared minus 4? How does that factor? It's a special one. Yep, this is called a difference. Perfect square. So 4 is a perfect square because it's 2 times 2. So the signs in here are what and what? You're on fire today. Addition and subtraction. Good job. And so the numerator, as I rewrite this one has 2 terms. Does it have some common factors? Is there something that can divide into 6 and 15? Yeah, 3. Do they both have an X? So I'm going to factor out a 3X. And then I'm going to write down what I have left. So 6 divided by 3 is a 2, and I'm left with an X. 15 divided by 3 is a 5, and the X goes away. So now I'm at a multiplication problem. So one thing I can do first is identify any values that would make this expression undefined. So X cannot equal. What does this tell me that X cannot equal? -2. So I have to look anywhere that there's an X. So what about this? A 3X. What does that tell me that X cannot be? I'll show you how I would do that. So I'm doing this kind of up off to the side. It can equal 0. So if it was 3X equals 0, I would divide by 3. What's 0 divided by 3? 0. So X cannot equal 0. So anytime you have an X, it doesn't matter how flared up it is. It could be 3X squared. It could be -7X squared. If it's just an X, it is always 0. Just like 6. 6 is just an X with a number in front. So anytime you have just an X by itself and it's not in parentheses, it's 0. So X cannot be 0. This one is a little bit trickier, but that's okay. We can do it. So we know that when it's in parentheses, it's the opposite sign, right? Okay, so it's still going to be -5. But because we're multiplying by 2, we divide by 2. So anytime it's written like that, and it's not just an x plus or minus, it's still going to be the opposite sign. And then you divide by whatever is in front of it. Okay, what can we do now? This isn't our answer. What can we do? So anything on the top can cancel or reduce with anything on the bottom. So I see an x plus 2 and an x plus 2. Does anybody see anything else? Yep. Anything else? So now I just write down what I have left. So I see there's an x minus 2, and then on the denominator, there's only a 3x. That's it. Because anytime that you find a factor that's in the numerator that matches a factor in the denominator, they reduce to just 1, so they disappear. Because they match exactly. Anytime you can find factors in the numerator and denominator that match up exactly. Are y'all good with this one? So if you're multiplying, you start out with just factoring, cancel, write your answers. Don't overcomplicate things. We ready for round 3? Madeline, you ready? Huh? It should change. I hope so. Because we were not good at that last. Oh, no, that's the money round.
Work.
Work. It's going out. Fate. Yeah. Family reunion. Yeah.
Things you tried to get sick. There we go. I feel like date was a pretty solid answer. All right, we're sitting at 6:13. After our next question, we'll go to the money round. All right, for this one, we are multiplying. So there's 2 things you have to do when you're multiplying and they look like this. They look different. There's no factors. There's nothing to really factor before we start. You have to multiply and you have to simplify. The order that you do that in doesn't really matter. So I am going to show you the way that I do it. It doesn't mean that that's the way that you have to do it. That's just the way that I do it. You can multiply, then simplify. You can simplify, then multiply. You can simplify some, then multiply, then simplify again. It doesn't matter as long as you get the right answer. So what I like to do is first just look and see if I can simplify any of the coefficients, because that makes things a little easier. So I just look at the number parts. So when I look at the numbers, 28 and 9, does that reduce? Nine goes into 27. 9 goes into 27. So that doesn't work. What about 9 and 3? Yeah, so 9 and 3 can reduce because 3 goes into 9 3 times. So this would become a 1. This would become a 3. All right, what about the 7 and the 28? A 1. 9 divided by 3 is 3. So 7 goes into 28 4 times. So this would become a 1, and then this would become a 4. Okay, so what I do is I simplify just the coefficients first. You don't have to, but that's what I do. And then I go through and I multiply straight across. So when I multiply straight across, I look at the coefficients. So this is like a 1 times 3 times 1, so it's just 3. And I know I'm going to have x's and I'm going to have y's. So when we multiply, we add the exponents. So I'm going to add across 3, 4, 5, 6, 7, 8. So I get x to the 8th power. Go through and count up the y's. So I have 1, 2, 3, 4, 5, 6. Only on the top. You have to do them separately. That's okay. For my denominator, I have 4 times 1 times 1, so it's just a 4. And I know I have x's and I know I have y's. So I'm going to count up the x's and I'm going to count up the y's. You do that too, just to make sure you know what you're doing. Did y'all get the same thing? All right, so before we go any further, let's identify what x and y cannot be. Hello? Yes, ma'am. Hi. Okay. Okay. So for this one, what can x and y not be? Somebody said it. They can't be 0. We can't divide by 0. So x can't be 0 and y can't be 0. They're not in parentheses. So it's easy. If they're not in parentheses, it's 0 every time. So now I'm going to go through and I'm going to reduce at the end. Can 3 over 4 reduce it all? No, so I'm good. So now I'm going to look at the exponents and I'm going to see who's bigger. Is 8 or 7 bigger? So I'm going to mark out this and then we'll subtract. So it'll become 8 minus 7. So what about 6 and 10? 10, 10's the magnet. So they'll go away on the top and I will subtract 6. So now all I need to do is rewrite it by subtracting the exponents. So the x will stay on the top. 8 minus 7 is 1. So I don't have to write 1. For the y's, 10 minus 6 is, there we go. That's it. For these, I can't divide by 0, right? Okay, if I cannot divide by 0, well, could x be 0? No. If it was a number, if it was 4 to the 7th power, that's not 0. So it could be that. It cannot be 0. So all my other classes after I did the Family Feud last time got way better scores than y'all because, of course, I didn't know how to do the money round question because it changes every time. So now if we do the money round correctly, maybe we'll get a better score. So let's see. Yes, I did. Don't make fun of us. I didn't know.
And you need something else, you might do it wide.
Ooh, that's a good one. Do we want paper or cheese? Airport?
Airport. Data professionals will often speak their clients to doctors. I was gonna say therapists. Beside the person named something. Trees.
I thought tree was pretty good.
Wait, are the circles drawn?
I think it's saying it was like a first answer or something. No, they got 19.
They're lost by a lot.
They got 1992,
They got a date.
1272. Y'all have room for improvement. I think it was that one question, like, what do you hide under the bed? Because we didn't answer all of them. But y'all did good. Y'all are getting good at this game. Has anybody like watched it? So you kind of know how it goes? I never really did. So I don't feel like I'm very good. Like if you've watched it, like if you watched it, so you feel like you know how the game's played, so you know the type of answers. So the last question, this is a subtracting question. What do we have to have the same in order to add or subtract? Denominators, what's our first step? Factor, do we factor everything? Just the denominator. Okay, so my first step is to factor. And as I factor, I'm putting things as factors. So like my numerator. And you do not factor the numerator, only the denominator. This is fast factoring. So it's things that'll multiply to give you 3 that could put together to give you 2. So 1 and 3 would work. My middle term is negative, so the 3 needs to be negative. And I would have to add 1. You guys have to listen. This is the last problem to review. Can't act like you don't know what you're doing if you aren't listening. Okay, so are the denominators the same? Sort of, almost. So we could get them to the same, but this one is missing the x minus 3 part. So I got to put this on here. We got to multiply by x minus 3. Now are the denominators the same? So let's go ahead and jot down my undefined values. X cannot be what and what? -1, +3, y'all are correct. And when my denominators are the same, then I can combine and the denominator will stay the same. I don't do anything to it. 1. For my numerator, I'm going to go through, and as I do this, I have to do 2 things. I have to distribute here, and I have to distribute in the negative. When it's addition, it's not that big of a deal. You just add straight across. But when you're subtracting, you have to distribute in the negative. So now I can rewrite everything. 3 times x is 3x. 3 times -3, -9. So that becomes minus x and plus 1. Can I clean up the top? It's minus -1. Yeah, I can combine like terms. I can put the x's together. So if I have 3x and I take away 1x, I would have 2x. And then if I have -9 and I add 1, -8, close. Yeah, I think y'all knew. Oops. At this point, what's always the last step when I am adding or subtracting? The first step is always factor the denominator. The last step is always before that. You want to see if you can. We did that. It's the very last step on the notes. Factor the numerator. First step is factor the denominator when you add or subtract. The last step is factor the numerator. So now we're going to see if we can factor the top. For this one, can you? There's nothing that divides into 2 and 8. Yeah, there is. 2 goes into 2 and 2 goes into 8. We're only going to pull out a 2. So I could pull out a 2 and then I'd be left with an x minus 4. Natalie, my brain goes fast like that too. And sometimes it sees automatically the groupings and I see 2 and 8 and I automatically think 4. They're little they're factor families is what they are. And there's nothing that I can reduce, and that's okay. Sometimes there is, sometimes there isn't. Sometimes things don't factor, sometimes they do. Those are minor points. You pretty much got everything except for the end. All right, we're going to turn in the warm-up and the practice, and we will start our quiz.